My name is Hardik Raj, and today we will be discussing the problem Eat Twice. This is an easy level problem and there are no prerequisites. This problem was asked in June Cook-Off. Let's look at the problem description. In the problem, we are given an array of pairs. The pair is something like this: di, comma, vi, where I belongs to 1 till n. Now, di is a dish served on the dith day. So actually, the dish served on dith day, and vi is the tastiness of the dish. It is the tastiness of the dish. I Okay, my pad is not working nicely. I don't know, it's weird right now. Dish. Right. What we want to do is we want to select two different days. So we have to select two distinct DIs and find the sum of the tastiness such that the sum of the tastiness is maximum. So we pick our objective is pick any two distinct days, any two distinct days such that the sum of the sum of the tastiness is maximum. Another thing to note is that on a particular day we can only eat one dish. So since we want to maximize the tastiness, what we will do is on any particular day, if we are going to eat a dish, then we are going to ensure that the dish that we have eaten has maximum tastiness. So let's try an example. We'll try. Okay, this is one test case. Let's try this test case. So here the value of m is actually not at all necessary. So we are given 5, 7. This is one pair. Then 1, 9 is another pair, and then 3, 7 is another pair. These are the days, and we want to pick two days such that the sum of the tastiness is maximum. So for sure, we want to pick this dish, and from this and this, we can either pick any of them. So let's say we pick this one. So the total tastiness is 16, and that is why it was 16. Let's take another test case, this one. We are given 5, 8, then 2, 5, and 5, 10. Okay, so since we know that on day 5 we can only eat that dish, we would like to eat that dish which has the maximum tastiness, and in this case 10 is maximum, so we discard this one. And now we have two distinct days, and okay, since there are only two, we pick this dish and this dish, and we get the maximum tastiness as 15. Now let's look at the code. So we first input n and m. Now we are maintaining day and tastiness. Alright, actually maximum tastiness on that day. So for each day, actually for each eye we look what is the day that the eye dish can be eaten and what is the tastiness associated with it. Then on that particular day we can either eat we want to eat the maximum tastiness dish. So in that case we just update the maximum tastiness dish on the DIth day using this. So MP of day is dish with maximum tastiness that can be eaten on day. Alright, since we need to pick two of those largest values, so I store the largest and the second largest. These are the tastiness values. The two maximum tastiness values. So we just iterate over our MP array or actually MP map. Now, if okay, this thing it calculates the largest and second largest in O of n. But since we are using, let me just use an unordered map. Unordered map. So this thing it will take O of n time. So let's see how this thing works to find the dish with the maximum tastiness and dish with the second maximum tastiness so that they do not die on the same day. Let's say we are given an array of integers 10, 1, -1, 7, 11. Okay. And in this case, the tastiness value is actually greater than equal to 1. So let's say it was positive 1 only. Alright, so we take two variables. The first one is largest, then the second largest. We initialize both with 0. Okay, now 10. So till now, largest is 0 and second largest is 0 and we encounter a value which is greater than both of those. So we update largest to 10 and second largest to largest. Or actually first we update second largest to largest and largest to the new value. Next, we encounter 1. Since 1 is not greater than 10, but we see that 1 is greater than second largest. So we just update the second largest. Now again 1. So 1 is not greater than 10 and 1 is not greater than 1. So we don't do any updates. Next we encounter 7. So 7 is not greater than 10 but 7 is greater than 1. So we update it as 7. Now we get 11. Since 11 is greater than 10, we first update second largest to largest and largest to the new largest. So using this, we are able to calculate the second largest and largest elements in O of n time. And that is what we are doing if the tastiness value is greater than or equal to the largest value. In such a case, we update the second largest to largest and largest to the current largest. Else, if our current value is just greater than second largest value, we update the second largest, and at the end we have output the maximum tastiness. So let's try to submit this. So as you can see, the solution was accepted. Now let's look at space and time complexity. The time complexity is O of n because, as we said, that we are calculating the largest and second largest in O of n time, and since we are using an unordered map, so the time complexity for traversing the map is O of 1. In average case, remember, whenever using unordered map, the average case is O of 1, but in worst case, it can go to O of n in case of collisions. But for now, this will not be an issue. So the time complexity is O of t into n, where t is number of test cases. As for the space complexity, it is just O of n because we are using an unordered map to store the day and the maximum tastiness. I hope you understood this solution and see you next time.